Hey everyone, this is Tom from Tutor Bros. Today we are going to learn how to solve third-degree polynomial equations by grouping. Now, as with other similar problems to these, this method can only be used in highly specific circumstances, but when it can be used, it is very simple, very straightforward, and, dare I say it, quite a bit of fun. So we have two examples here. Let's go through each of them together. We'll take a look at the first one on the left. We have x cubed plus 3x squared minus x minus 3 equals 0. So if we're solving by the grouping method, the first thing we want to do is put parentheses around both pairs of terms, the first and second term, as well as the third and fourth term. So just like that. Then we want to factor out the greatest common factor from each of the two pairs of terms. In the first pair, our greatest common factor is going to be x squared. So when we factor out an x squared here, we are left now with x plus 3. And then we'll do the same thing with the second pair of terms. There's really nothing to factor out here other than a negative or a negative 1. So we will factor that out, and I think that will be to our benefit, and you'll see why in just a moment if you don't already. So when we factor out the negative, then the expression in the parentheses now becomes positive x plus 3. So you'll notice that there is another common factor in both the first and second terms, namely the binomial x plus 3. So that's why it helps us to factor out the negative. Okay, so now we will factor again. We will factor the binomial x plus 3, and then we'll see what we can do from there. So when we factor out the binomial from each of these two new terms, we'll have the x plus 3 out here. And then what are we left with in each of the other two terms? Excuse me. So in the first term, we have left an x squared, so we'll put that in parentheses here. And then in the second term, we don't have anything outside the parentheses except that negative. So we can express that as a negative 1. So when we rewrite that, we'll bring it over here as x squared minus 1. And then this is still all equal to 0. Then we're going to employ the zero product property, which you'll remember tells us that if we're multiplying a bunch of things together and the answer is 0, then at least one of our one of our factors has to be equal to 0. So we'll just take each of the parenthetical expressions, set it equal to 0, and then we'll solve for x. So the first expression would be x plus 3. And when we set that equal to 0 and solve for x, we find that x is equal to negative 3. So that is one of the solutions to our original equation up here. And then we'll do the same thing with the next expression, which is x squared minus 1. We set that equal to 0. We'll use another line for this one here because this is a multi-step problem. We'll add 1 to both sides. We get x squared equals 1. And then we have to take the square root of both sides. So if we take the square root of x squared, that would just be x. If we take the square root of 1, that's going to be 1. But it will also be negative 1. So don't forget to take the negative square root as well in these cases. So we have plus n minus 1. That's another solution, or two more solutions to our original equation. So our final answer here, our values for x that would satisfy the above solution would be x is negative 3 and x is plus or minus 1. Alrighty, now with that in mind, let's do the second example problem together. First thing we'll do, we will group each two pairs of terms. Then we will factor out our common factor. So we have, in the first pair of terms, we have x cubed minus 2x squared. Greatest common factor, same as in the first one, is going to be x squared. And then we're left with x minus 2. And then in the second pair of terms, 3x minus 6, our greatest common factor is going to be 3, which is a positive 3. So plus 3. And then we're left with x minus 2. So once more, we have the same binomial expression in each of our two new terms. And we're going to factor that out in the next step. So that binomial x minus 2, we factor that out here, bring it out, x minus 2. And then we're left in the first term with x squared, and then the second term with plus 3, all of which is still equal to 0. All right, then we set each of our parenthetical expressions, each of our factors equal to 0, and then we'll solve for x. So x minus 2 is going to be equal to 0, and then when we solve for x, we find that it is equal to 2. Then we'll do the same thing with the second expression, x squared plus 3 equals 0. We subtract 3 on both sides, we'll have x squared equals negative 3. Now it looks like we're going to have to stop here because we can't take the square root of both sides of this equation because negative 3 is negative, and we can't take the square root of a negative. Technically speaking, we do have what's called imaginary roots, so you may have learned about that in class already. But for our purposes, we're just going to stop right here and say that x squared equals negative 3. There's no solution to that, or no answer, so we'll just put NA here. So the only solution to our original equation up here is going to be x equals 2.